Everyone saw the keynote demo? Pretty cool. You saw some funky query full text search capabilities out on the server side, Couchbase Server 5.0. Now I'm going to talk about some of the cool capabilities that Wayne alluded to coming up in Couchbase Mobile 2.0. I'm Priya Rajagopal. I am a developer advocate here at Couchbase. And so everything that I'm going to be talking about today is going to be available in Couchbase Mobile 2.0. Couchbase Lite 2.0 is currently in developer preview. If you've been attending some of the sessions earlier today, you probably had a good overview of 2.0. If not, these are some of the highlights. It's completely re-architected from the ground up. Compared to 1.x, we have a new C++ Lite core engine, a brand new replication protocol that's WebSockets based called Blip. We have a new binary encoding of JSON documents, Fleece. The inventor of some of this is right here in the audience, so ask all the tough questions to Jens. The API, we have platform-specific API, again, completely redesigned from the ground up. The core engine, of course, is C++ and platform agnostic, and then you've got a platform-specific area. And of course, the key is Nickel query and full-text search interface. I'm probably overstepping here by saying Nickel query. It is Nickel. It's going to be a subset of some of the capabilities that you see on the server. But regardless, if you're used to the map-reduce views in 1.x, you can forget all about that because we have a new query interface. So how many folks over here are familiar with Nickel, played around with Nickel? OK. But SQL? OK, cool. So hopefully a lot of what is discussed here would seem pretty familiar to you if you're familiar with SQL. That's one of the intentions of Nickel is a SQL for JSON documents or NoSQL documents. So over here, this is the very basic query. What you're doing is querying for all documents from a given database. And everything over here applies to Couchbase Lite. So you do a select and select result.all. I'll talk about that in a couple of slides down. But essentially, what you're doing is specifying the properties of the documents that you're interested in. So select result.all means you're interested in all the properties of the document that meet the specific query criteria from a given database. Pretty straightforward, right? The result is an array. It's basically an array of JSON objects. Each JSON object corresponds to the document that fits or that satisfies the specific query. Now, this part of the matches and the enumeration and processing of the results, that's not going to change across queries. So I'm not going to spend any of the slide real estate devoted to the matches. I'm going to just focus on the query side of things. So this query, simple query, getting all the documents in a database. But obviously, that's not very practical. You probably want to limit the number of documents you're going to get. So pretty straightforward. You can add a limit clause and say, OK, limit gets this many documents from a specific offset. So you can achieve pagination. Next, select result and query expressions. I spoke about, or I demonstrated select result in the previous slides. So what is the select result? It essentially returns a single return value of a query statement. You got select result all. It returns all the properties in a document. Or you can actually filter it and say return only specific values based on a certain expression criteria. Now, what's an expression? An expression is something that we use for constructing a query statement. There are a whole slew of expressions. You've got property, aggregate, string, collation, regex, full text search, null check, and so on. And through the rest of my talk, I'm going to try and cover most of these query expressions. I'm going to give examples of that address most of these. And I hope you have made a note of all of this, because there's going to be a quiz at the very end, and you're going to have to tell me which ones were covered and which ones I left out. So the very simplest kind, property expression. So if you remember the previous query where you queried for all documents. You did a select result.all, right? Now, replacing that select result with a select result.expression, in this specific case, it's a property expression. So what I'm doing is querying for all documents subject to a certain limit and offset, but then I'm only interested in the name property of the document. So my response is going to be an array of JSON objects, and each JSON object is going to have the name property. That's cool. But then you're probably going to have a nested document, something like this, right? And what if you're interested in the lat longitude, right? So you can specify key paths. So this is going to basically return back the geo.lat and the geo.long for each of the documents that meet the specific criteria. Now, every document in Couchbase Lite, you've got the data part of it, and then you've got metadata. Now, the metadata includes stuff like the ID, things which are not something that the application developer needs to worry about or mess around with. So what if you're interested in the IDs of all the documents? You're not interested in the data, but just the IDs. So you can do that by select result expression, and you have a meta expression that you can use, or metadata expression, sorry. And this is going to be your result. Pretty straightforward. Obviously, you can add more. You might be interested in the metadata as well as all the data. So if you run a query, something like this is going to be your result. So notice that you have the ID, so every object. So let's consider the first object, right? I mean, you've got an ID. That's the document ID. And then the JSON body itself, and that comes back as an object which is of type, a JSON object, but then the key value of that corresponds to the name of the database. This is something that you need to be aware of. It's similar to how Nickel does it on the server side. So again, this particular query expression, you've got select the metadata and select all. What if you're interested in metadata and one specific property? In this case, the name property. Over here, notice that in the previous case, if you remember, you get the ID, and then you get the name of the database and the entire JSON document. Over here, you get the ID and the specific properties that you're interested in, and in this case, it's name. So far, what we've seen is, okay, how do we filter out the properties of documents that we're interested in, right? But what if you're still querying for all the documents. You're asking for all the documents, but within the document, you can actually specify the subset of properties that you're interested in, and that you do with the select result. But you might obviously want to actually filter on the documents itself, right? And that's where the where clause comes in. Again, if you come from the SQL world, this should be very, very familiar to you. So in this particular example, you have select all the properties for the documents from the database. And this is your selection criteria. You include a where clause. And in this specific example, you're saying it's a comparison expression, where you're saying this property type equals to a value type. I mean, I'm just using type, but then assume the type over there is type of hotels, landmarks, right? Airlines, whatever makes sense. Now, logical expressions allow you to concatenate expressions to make something much more powerful. So in the previous case, you had a simple example. You said, get me all documents whose type property is equal to some value type, correct? So in this example, property type is equal to the hotel. That's a comparison expression. Now you can concatenate it using a series of logical expressions, where you can say that, okay, I'm interested in all documents of type hotel and the documents where the country property is equal to United States, or the property country is equal to France, and the vacancy is equal to true. So essentially, I'm interested in all hotels in the United States or France which have a vacancy of true. pattern matching. So you can achieve pattern matching with the like query, very similar to SQLite. So in this specific example, you're saying I'm interested in all documents where the expression, property expression is equal to landmark, and the property name is equal to, it's not like equal to, it matches the pattern engineer. So it's a like expression, it's case insensitive match. So it's going to match something like this. You know, Royal Engineer Museum, you notice that engineer in the response has got a capital E, does not matter because it's case insensitive. But you probably, this is an exact match. So only if you find the word engineer in the name, it's going to return the document, right? But you probably want more flexibility, and you can do that using wildcard matches. So use the percentage before or after or anywhere in the like expression. And so in this particular example, it's going to match all of these. You're going to get Royal Engineer Museum. You know, it's in a single word. It can be split up among words. So the second word, the second name, Bengal Raj, you can see that it actually still matches ENG wildcard R. It's split up between two words. And the third one, again, because the percentage is a wildcard, it matches 0 or more characters. That's pretty cool, but what if you actually want to specify the exact number of wildcard characters? And you can do that. So you use the underscore. So in this, while it's not very clear in this particular example, actually between the ENG and the R, there are 4 wildcard character matches. And so it's going to match, in the results, it's going to match something like this. Because between ENG and R, there are exactly 4 characters, I, N, E, and double another E. Now, similar to like, we also support regex matching. So you can construct any powerful regex expressions. Now, if one would ask, when would you use one over the other, like over regex? I mean, remember that like is case insensitive match. Regex matches are case sensitive. In this particular example, you're going to match on word boundaries. You use the /b to specify word boundaries. You're going to match anything which which starts with ENG and has 1 or more characters, 0 or more characters, and has an R somewhere in the middle. So it's going to match this word again. To me, personally, I like this. I mean, I think this is really powerful, actually trying to look for documents where a property does not exist. It's really straightforward. Just use is null or missing. So that way, you can actually query for all documents where a property value is null or a property doesn't exist itself. And that goes with one of the power of JSON, right, and the flexibility of the schema. So it's not required that a particular property exists in the document. You know, as it evolves, you might add new properties, and you might be interested in knowing documents which conform to an earlier version of the schema where a property does not exist. And that's the null check expression. Ordering, very straightforward. You can order based on a property, ascending or descending. And this, again, is pretty powerful when you use it in combination with the select, from, where, and limit clauses. Collections. Now let's consider the example over there, right? You have a document, a very simple document of type hotel. It includes an array, a nested array, public likes. Now, what if we want to query all the such documents of type hotel, but you're only interested in documents where the public likes array contains a specific value? And you can do that using the array contains function. So using the array contains function, you can basically say, you know, it's pretty straightforward. Okay, if public likes contains the value anime, you know, that satisfies the where clause. in conjunction with a logical expression, a logical AND expression. You can use it in conjunction with the type property check, right? So that's cool. Right now, using this, you can return all documents where the public likes array includes the specific value. But what if you're interested in, well, get me all the documents of type hotel, but I just want to know the number of public likes, right? It's like the star rating. So I want to know the number of public likes. And you can do that in the select result expression, where you can say function.arrayLength. So this is going to return you the array length of the property. And over here, naturally, the property expression, public likes, has to return an array object. And if you run an expression query of that kind, you're going to get a result like this. Not bad. I mean, you see the $1 and you say, okay, 3, the count 3, but what's $1? What does it correspond to? You can use aliasing. So in this specific case, I can say, okay, get me the array length, and this is the expression on public likes as. So you use the as to alias the result. And so the response to that particular query would now alias the count, the public's like count, with number of likes, because that's the alias that I gave. The satisfies expression is a little interesting, and it'll take a few minutes to wrap your head around this. At least it took me a few minutes to wrap my head around this. Again, consider the same document, the same array, public likes. It's got a bunch of elements, right, in the array. What if you want to check for a specific condition on every element of the public's like array? Or what if you want to check for a condition to see if any of the elements of the public likes array satisfies a certain criteria? Did that make sense? So you want to it still applies on a collection. You want to apply it on an array collection, but you want to check to see if a certain criteria is satisfied by one or more elements in that specific array. So this is how you do it. You declare a variable of type reviewer. I mean, I'm giving it a name and saying reviewer. You use the any expression. So take a second to look at what's happening here. You're saying check if whatever is returned by the public's like expression, so by the in clause, and over here that returns an array object. Check if any of the elements in the public likes array satisfies the specific criteria. And you're using the pattern matching clause, that's the like clause, to see that if it includes the name Alice. So you're just checking to see if Alice has liked any of the hotels in the list. Okay? Give you a second to just look at that. And now, along the lines of you just saw the variables, right, and how you could use variables in a satisfies clause, you can actually parameterize the functions and can do something very powerful and cool with it. Now, a couple of slides ago, I discussed a scenario where you might be interested in the number of public likes, right? I mean, you want to query for all the documents of type hotel, but I'm only interested in the number of likes associated with each of those hotels. But what if I want to extend that? I'm interested in number of likes. Sure, give me an absolute number, but I'm also interested to see if the number of likes is in a specific range. I'm only interested in hotels, like for example, assume these public likes are like a star rating, right? So I'm only interested in hotels where the star rating is between 3 and 5, okay? So how would you do something like this? Remember how you determine the number of the length of an array? Use the function array length. You can, over here, everything that you see here is Swift. I mean, the same thing applies to Java or any other language.NET. So you've got the likes count. This tells you the number of elements in the public likes array. You define two parameters, a lower and an upper bound. That's just the name that I've given. And this is the same as the previous case where I say, OK, give me the result aliased as number of likes. And then you see the range expression. But I'm only interested in documents where the number of likes or the likes count is between a lower count and the upper count. OK, so far you just defined two parameters, lower count and upper count. But what is the lower count and what is the upper count? You can set those values here. So by running this query, you're going to get back all the documents where the number of likes is between 5 and 10. Okay? Of course, with any query, when you're processing JSON documents, you need string operations. You've got the standard list of string functions, lower to upper, substring, left trim, right trim, and so on. And this is very straightforward. All you're doing is, OK, get me all documents where the email property includes the substring nationaltrust.org. OK, nothing much to it. Now you can enhance that using collation expressions, where you can actually apply it to Unicode character sets. By default, it's to ASCII, and then you can specify that, no, I'm dealing with Unicode. And I'm also want to make sure that while we are doing the string operation, ignore the case. Or in this specific case, I say, well, in this specific example, I say don't ignore the case, so I want it to be case sensitive. So get me if whether a country property subject to the collation expression, so which means apply it to this Unicode string. Don't ignore the case, and return me everything that matches United States. Count. I think anyone reading this expression can infer what it does. I'm interested in a count of all the documents that meet a certain criteria. And the criteria, again, you specify in the where clause. Very straightforward, because I use the alias as, and I say number of hotels, and the function count gives me the number of documents that match that, which are the result of the running the query. And in this case, you get number of hotels, whatever number, 917. OK, that's cool. But you probably want to do something a little more powerful. What if I'm interested? Now, let's just assume, for the sake of this example, that associated with these hotel documents, there's also a country property. Okay? So you want to group all the hotels by country, and you want to know the number of hotels grouped by country. So you say, OK, get me the country, and group it by the country property. Your response is going to be something like this. So in my data set, I've got hotels which are located in France, United Kingdom, and United States. And this is the distribution of the hotels in those 3 countries. Now, I'm going to give one more example related to this, which can be a little confusing, but I wanted to point that out. Let's say the same thing. I'm going to get the number of hotels. But instead of country, I query some other property in the document. Let's say the name. Again, I'm grouping it by country. So again, my intent over here is to try and get the names of all the hotels grouped by country. You try to run a query like this, you're going to get something like this. So it's just going to return the first hotel in that country. And that's not probably what you want. We don't have an equivalent of array aggregates, which is there on the silver nickel side as yet. But I wanted to point it out there, because if someone tries this and see something like this and is wondering what's going on, yeah, there are some limitations or at this point, at least as of this developer preview. Okay, joins. So this is obviously something very powerful, exists in SQL. Now, how does it work in the NoSQL world? Consider two sets of documents. A document in green called favorite list. That's of type favorite list. And then I have the documents in blue, which is of type landmarks. So the document of type favorite list, it lists my favorite things, and my favorite country, hobby, pet, sport, and so on. I must add, it actually is not my favorite list. I mean, I don't even play golf, but for the sake of example, let's just go with it. So what I'm interested in is, okay, look at my favorite list. And for the country that's listed in my favorite list, I'm interested in all the landmarks in that specific country. So there are two landmark documents which are in that specific country. That's good. So you do this using a join clause. So you're joining document of type favorite list where the country matches the country in the landmark document, right? Now, while the second half of what I'm going to say is not part of the join clause, it makes it much more powerful because, okay, now I've joined, I've got two sets of documents, I've joined the contents of the two documents, right? But now I'm going to look at the hobby. And, okay, I've got all these documents, landmarks, which are in France, but among those, I'm only interested in those where the content matches my hobby. So in this specific example, doesn't match or, it contains something related to my hobby, right? And my hobby is museums, like going to museums. So let's say you want to do something like this. How would you achieve that in Couchbase Lite 2.0? You first define your data sources. Now, in a traditional SQL world, you would have different tables, right? And you would try to join across the tables. Well, here you don't quite have that, right? It's a collection of JSON documents. So how do you do something like that? You can start defining data sources. So you define the favorite data source, and then you define a landmarks data source corresponding to these two sets of documents that you're interested in. Look for the property country from the first data source. And again, the same property. Remember, we are trying to match the country property, which is in the document of type favorite list, with the country property that is in the document of type landmark. You specify this as your joined expression, where the country expression is equal to landmark expression. And I'm interested in those where the type is equal to landmark and where the type is equal to favorite list. And then you can do an inner join. There are other kinds of joins available as well, like auto join and so on, but then the basic idea and the basic way you construct a query is similar. So at the end of the four statements you see over here, you've actually joined two sets of documents based on a specific property. And in this case, it's the country property. Now let's get to the second half of my example. Right? Now I've joined the contents of that, but I'm only interested in those where the content includes my hobby, and my hobby is museums. So you can do that with the where clause, where you can use the functions, you can use a string, you can use anything. I mean, you can use pattern matching and maybe even full text search that we'll look at in a bit. But in this example, I'm using something very straightforward, and I just use string, substring, expression. And that's it. Using this, I can actually join the contents of two documents and filter it based on a specific criteria. So everything you saw over here, it falls under the umbrella of query. And making the query all the more powerful is full text search. So in order to use full text search, you have to define a full text search index. Now, as with SQL style querying, right? I mean, you define indexes, it's going to speed up your queries. There's obviously going to be trade-offs when you define indexes and so on. But in all the previous cases, you have the option of creating an index if you want to speed up those queries, as long as you understand the trade-offs. I didn't do that in any of the examples, but you can do that. But when it comes to full text search, you have to create a full text search index. So some of the options that you can specify as part of the full text search index is obviously the property on which you want to index. You can specify the language. Then there are certain other options which are available, like whether you want to ignore the accents and so on, language-specific stuff. You create the index, and you have to do it front before you run the query. And this is it, the match expression. So if you've done SQLite, you're familiar with match, you use the same thing over here, and that is essentially full text search. This particular match expression is going to look for the words terrible or bad in the reviews. Now, very closely linked with full text search is a rank order. So what is a rank order? Rank order basically specifies, it's like a weight that you assign to a match. So if something, in terms of a full text search, if something matches more closely than something else, then that's ranked higher, okay? So for example, in this is the same thing. Here's a rank expression. So in this example, I'm looking for terrible or bad in the reviews. Now, let's say you have got 2 reviews, in one of which you have the word terrible, and then in the other one, you've got terrible and bad. You probably might have the second review ranked higher than the first one because it's got both the words. And you can specify, okay, I've got this rank order. You use the function rank to say, okay, I'm interested in the ones that meet the criteria first. I want to sort that in the descending order. So the one which has got the closest match is going to show up first. So there are some limitations, and this is not, the match can only appear at a top level or a top level and expression. It's case insensitive. It's not a limitation, but it's just that it's case insensitive. And then you also have stemming support. We saw some of that in the demo earlier today. These are the languages which is supported. So stemming is basically you can have the plural forms in the tense and so on. At this point, there isn't fuzzy logic support included as yet into full text search. And in future, the hope is to have platform-specific tokenizers as well, which would allow you to leverage your own tokenizers. If you have got a language tokenizer for Mandarin and you would like to use that, we want to open it up so you can actually do full text search based on the tokenizer that you have, and you can plug in third-party tokenizers. So basically, that was a quick whirlwind tour of the query and the full text search capabilities available today in Couchbase Lite. It is in developer preview. Everything that I discussed here today works, has been tested out. I mean, I've got apps running there using these. So download this. There's still opportunity for iterating over this, and we'd love your feedback. So it would be great if you can try it out. Join us on the discussion, developer forums with any updates, any questions. Everything is on GitHub. So any of these that I discussed today, if they don't make sense or you would like a better way of handling that, we'd like your feedback. And of course, I'm available on Twitter as well. So that's all I had for today. And if any questions? Yes.
Looks really powerful. I guess one question is the equivalent
Yes, so the question for those who didn't hear was, are live queries still available in 2.0? And the answer is yes. So yes, as part of this, you can run a live query. Yep.
So any of these queries can be set up as a live query?
Yes.
How about geospatial, like the where clause, like specify some bounds?
Well, geospatial, I'm going to direct that question to Jens.
Not in 2.0, but we've had several requests for it, and it won't be too hard to do because there is support for that in the underlying SQLite database. So hopefully in 2.1.
Thank you. So for those who didn't hear that, it's not there in 2.0, likely in 2.1. Any other question? Yes.
What about dates?
We do have date time. Time.
There's not a built-in type for it, and I don't think that we put in all of the date parsing functions that Priya called. But in general, in JSON, you store dates in ISO 8601 format, and that format happens to sort correctly if you just treat it as ASCII. So you can do things like comparing dates or finding dates within a range just by treating the date as a string. But more elaborate stuff with dates, you have to bring back the results from the query into your native code and then parse the dates and then operate on them that way.
Yeah, so the short answer is no built-in support for date parsing, but then you would use the ISO 8601 string format and treat it as strings and use any of the comparison expressions. Thanks. Anything else? Nope? Cool, thank you very much.